What is up, all you motorheads? Welcome back to another video from Shift Happens. Now, today we're going to address three things. One, the big one that hurts my heart, is the Buffalo Bills lost the playoffs to the Broncos. I don't care what anyone says in my comments, that was a catch. Hands down, 100%, that was a catch. Two, I found out a little bit more information on that Billet carbon fiber engine block I featured in my last video on that Instagram post. And three, my comment section has pointed out something that I didn't know previously existed, and it is a plastic engine. So I'm going to give credit where credit is due. Post-Scrapped, a company in the 80s called Polymotor made a working plastic composite engine. 2 liters, 280 horsepower, less than 200 pounds. They even went on to make Polymotor 2. Now, Post-Scrapped, thank you very much for that comment, because now you just put me onto a rabbit hole that I cannot get out of. As for everybody else who had things to say in the comments, I really appreciate reading all your comments. It was really nice to see how everybody thought about this. And a lot of you had very great points. Very great points. And it has caused me to look into a lot more material testing and material sciences, and to see how things actually can work. Now, we're just going to go down that list. So, as for the Billet carbon fiber engine block, I got a message from somebody and they wished to have their messages not shown, talking about where I should be looking for that specific engine. Well, that prototype, or however you want to call it. Now, I did find something they told me to look for, and it was Cosworth/Advanced Engines Research. They told me to look there. They said I would be blown away by some of the information that is available. But that Billet carbon fiber engine block is actually a VQ-based engine. Now, Advanced Engine Research, also known as AER, has been around since 1997. Now, the specific engine that I was told was, I believe, the P6. I believe it was the P60. But yes, here's their Wikipedia page, and this is their main website right here, Advanced Engine Research. And yes, this is it. The P57 GP3 V6 3.4 liter naturally aspirated engine that was built and serviced by AER exclusively for the GP3 series. It features a fly-by-wire and is an all-aluminum fully stressed engine and is designed for lightness and to operate a full season without servicing. Now, this is what I was told that Billet carbon fiber engine block was supposed to be going to. I don't know how true this is, considering I cannot verify anything about that photo. I can't even verify where it came from. But this is where I was told to look by somebody who's involved in IndyCar racing. And that's all I'm going to say on that. I'm sorry, but I had to say it. But this person told me to look here and look into Project 57. So I, again, don't know how true this is, but if anything, these are all V6 blocks, but they're billet aluminum. Now, I haven't gotten a hold of any of these people yet, but if I can, I will put out a post addressing that picture. I will see what I can find, but again, The only things I can find on that photo is a Facebook post, an Instagram post, and one post in r/f1 in Reddit. And again, it was a VQ-based engine, and that's pretty much it. Nobody can verify where that photo has come from, as far as I know. This is the only instance I have found where somebody told me to look in this direction, and this is what I found. But going off of that, going on to the plastic motor from Polymotor. I, again, never heard of this until I started reading my comments from Postscript. Now, this is what Polymotor is. This is their website. This is what I've been looking into and figuring out, like, anything I can about these things. All the power without the weight. 161 pounds. Polymotor 3D P3D uses carbon fiber and 3D printing of composite and metal parts, so it is now 16 pounds lighter than the Polymotor 3 and is 10 brake horsepower more powerful thanks to the OBR engine management system. In 2020, a naturally aspirated P3D will power a sports prototype in the Farah USA Series in Homestead, Florida. In 2021, a turbocharged P3D may return to hill climb and possibly Pikes Peak. I haven't been able to look into that to see if that actually happened. But here's just a little bit more about these people, because, again, this is amazing to me. In 1972, Matty Holtzberg established Polymotor Research to develop fiber-reinforced polymers that could be used to replace metal parts in internal combustion engines. Ahead of its time in 1980, he successfully created Polymotor 1, the world's first polymer engine. Holtzberg designed and developed Polymotor based on a Ford 2000cc engine with a cast iron block. His polymer design weighed just 180 pounds, about half the weight of the metal engine, and produced 280 brake horsepower at 8,500 RPM. A plastic engine, by the way. A plastic engine was made, weighed 180 pounds, and produced 280 brake horsepower. That's, again, this is some pretty cool stuff. I didn't know any of this existed. In 1985, Holtzberg shocked the global automotive industry and motorsports world by successfully competing in the IMSA Camel GT Championship, later in the Gulf Oil British Hill Climb Series, where it blitzed massive 2-liter opposition by beating the top 2-liter racing engines in the UK and Europe with what was essentially the world's first polymer race engine. This is amazing. Like, thinking about a plastic engine, something like this, is wild to me. Because this only reinforces people, like, getting a 3D printer and going home and making something useful out of it. Not your typical trinkets and all that fidget toy shit. No, somebody nowadays, for instance, I've seen somebody on YouTube, I can't remember his name off the top of my head, but he made a 3D printed engine and made it run. Now, these people just happened to do something, I have no idea how they did it, but they happened to do something to create a plastic engine. In response to the growing demand for lighter, more fuel-efficient cars from global automakers, Holtzberg took his design to the next level and created the Polymotor 2 and 3, using latest fiber-reinforced polymer materials for manufacturing engine blocks. The Polymotor Polymotor 2's polymer engine block, oil pan, cam box, and cam cover are molded using a fiber reinforced thermoset holding compound and a molding process developed by Holzberg. The Polymotor 2 and 3 block weigh 6 kilograms less than the Ford's latest EcoBoost 2.0 aluminum block. If these cars are still holding the horsepower that they are, and they weigh less than the EcoBoost currently, well, I'm sorry, as of 2021, because that appears to be the last time this website was updated. That's insane. Today, the world's, I can't click. Damn it. Today, the world's first polymer engine is rapidly becoming the world's first 3D printed metal and polymer engine using both 3D printed polymer parts as well as 3D printed metal parts. The camshafts are 3D printed in Inconel 718 and DLC coated, and the 3D printed aluminum cylinder bores have a proprietary coating on the bores. The next metal parts to be 3D printed are the titanium valves, steel tappets, titanium connecting rods, aluminum for hill climbs, and a super light hollow steel crankshaft. The latest dry sump oil pan design will be 3D printed using carbon fiber thermoplastic. Now, I don't know about the hollow crankshaft, but just looking at some of these photos, like that's a plastic engine block. Like, that's a terrible photo on their website. I don't know why that is the way that is, but yeah, just looking through some of this stuff, like it's a plastic engine. I don't know how this is possible. I would love to find out more information about this. I would also love to find out more information on that billet carbon fiber engine block, but this will suffice for the time being. Considering this thing was raced and actually used, and it shows some sort of possibility of it working out, like especially in 1985, like this was being done. And like they're obviously still around making this. Like I wanna know more about these. But like there's virtually nothing left on their website. Like I can't find anything other than this really. I'll try looking into more articles, seeing if I can find out more information, or even if this company is still around, considering their website hasn't been updated since at least 2021. But yeah, like this is amazing. I love when somebody puts a comment out there into the world where they have a level of knowledge in something that the video creator has no idea on, and this just reignites my passion for doing this. That comment led me down this rabbit hole, and I can't be any more thankful about it. Like, here, on. Well, postscript. Seriously, from the bottom of my heart, thank you for that, because I'm going to be doing a lot more research into this, but I wanted to make this just for the short video format. But seriously, thank you. But now we're going to get into the third thing that I wanted to look into was AWA, because I also got another comment about AWA and forged composites. And I wanted to look into this as well, but this is not nearly as exciting as the Polymotor. That thing's amazing, in my opinion. But AWA has been going bonkers they've been risen with the tism on on composite materials being used for engine parts, like composite rockers. Carbon composite rockers reduce weight and enhancing power output. Material is 1.5 times stiffer than 4130 steel, improves valve displacement accuracy, promotes efficiency, power, and valve train durability, effectively addresses and mitigates harmful harmonic vibrations in high-performance valve train systems, ensuring smooth operation. That's cool. That's really cool. But I don't see, I think this is only for like high-end, like ultimate, like high-end cars or like drag cars or something like that. Because if you look through the rest of this, composite retainers, 65% lighter than their high-performance titanium counterparts, significantly reducing the weight of each valve assembly, maintains dimension strength even at elevated temperatures, ensuring durability within the engine. High stiffness and material composition effectively mitigate detrimental harmonic vibrations, enhancing valve motion accuracy and prolonging engine longevity and operational effectiveness. 65% lighter than titanium. It's like, this stuff is crazy. But like composite push rods, 70% lighter than the steel. Remarkable 4.5-pound weight reduction in standard valve train setups. Composite connecting rods, handles up to 12,000 horsepower. 40% lighter than aluminum connecting rods. Far less fatigue, reduces harmful harmonic effects. Proprietary rod bolts used. Patented technology. Don't really care about that part. Now, I want to see these being used, but for the purposes of this video, I'm just going to try and keep everything quick. That is cool. Composite pistons, 40% lighter than aluminum pistons, superior thermal, allows for tighter tolerances and clearances for more effective ring seal. Wrist pins, lifters, like the wrist pins handle 12,000 horsepower. Like, something about this tells me that it's only meant for like top fuel cars or drag cars in like their highest potential points. But like, they've got their stuff down. The only thing is, there's no test data or like anyone actively advertising them using these rods. So, well, that I've looked so far into it. I've only looked so far into this, so I don't know for sure. But there's nothing on their website, so I don't take that how you will. But yeah, this has been very interesting. I to casually admit something, I was watching my YouTube like all night over Sunday into Monday. Like, y'all who've came in and watched that video and shared a comment or liked the video or subscribed to my channel, thank you very much. I didn't think I was going to hit that amount of views, that amount of likes for a while. I thought I was going to be waiting a bit for something like that to happen. And the fact that all y'all did come in and, you know, watch the video and even grace me with the comments that you had, not all of them were positive, but they were still there. And I want to thank all of you for taking the time out to do that, because I really like doing this. I like sharing information about something I'm passionate in. And now that I'm getting more and more information from you guys in the comments, like, I want to keep doing this, because if you guys can make me smarter, like, I don't know what to say, because my bus to school was very steel deficient. And half the time I may or may not have had to wear a helmet. But regardless, Thank you all for taking the time out. I really appreciate it. Now, I'm just going to end off the video here. Thank all you motorheads for stopping by. Remember, check out these 2 videos and or subscribe. Come back for a while. But until next time, I'll see you later.